Good morning all. My name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Architecture. Today I am discussing about problem solving on any radix to decimal conversion. So what are the possibilities are there for any radix to decimal conversion? So any radix means, suppose we have to convert to any radix to decimal. So any radix means maybe it is binary, or maybe it is octal, or maybe it is hexadecimal. So if we have to convert to binary to decimal, octal to decimal, hexa to decimal. So any radix we are converting to the decimal. So any radix means, what are the possibilities means, binary to decimal, octal to decimal, and hexa to decimal. So here suppose I am taking binary values 110, 110, 11. Example I am taking. This I am converting to the octal. But here we are going for the decimal. So any binary to decimal, any radix. Suppose I am taking 548, 547, 8 conversion to hexadecimal means 1AF 16 to decimal. So these are the examples we are converting from binary to decimal, octal to decimal, hexa to decimal. So these are the possibilities of any radix to decimal conversion. So what is the process for any radix to decimal? Step 1. Determine the column or positional value of each digit. This depends on the position of the digit and the base of the number system. Multiply the obtained column values in step 1 by the digits in the corresponding columns. Sum the products calculated in step 2. The total is the equivalent value in decimal. So left side, any radix we have to take binary, octal, or hexa. So we have to convert to decimal. First, to determine the column or positional value, each digit depends on the position of the digit. So what are the digits we have to take, and the base of the number. So what is the base? Suppose I am taking here base 2, here base 8, and here base 16. I have to convert to the decimal means, what is the decimal means? Base 10. And multiply the obtained column values in step 1 by the digits in the corresponding columns. So we have to multiply with base value. So what are the values here I am taking? 547. So these values we are multiplying with base value. Here 1AF. These values we are multiplying with base value. And sum the products calculated. After the multiplying with base value, we are adding the values as per step 2. And what is the total value we have to find out. That is the final value with a decimal. And what is the technique for this one? Multiply each bit by r power n, where n is the weight of the bit, r is the radix or base. The weight is the position of the bit starting from 0 on the right. Add the result. So what we are taking the values? 547 I am taking. Base 8. We are to convert to decimal. So these values, so I am taking from LSB to MSB. So these LSB to MSB I am taking as the r power n. R power n means it is a 8 power 0 position, 8 power 1 position, 8 square position. Why I am taking here? Base is 8, like this. So LSB to MSB, we have to take the position of r power n, and it is also called weight of that one. So what is the weight means? 8 power 0 means 8 first position. It is a position 1, position 2, position 3. So we have the 3 digits. That is the reason I am taking 3 positions. So 8 power 0, 1 position, 8 power 1, 8 square. And the weight is the position of the bit starting from 0 on the right. So we are taking from 0, 1, 2. So right to left we have to take. And first I am taking, there are so many possibilities are there for decimal conversion. First I am taking binary to decimal. Also we have octal also we have possibility. Hexa also we have to possibility. But first we have to take binary to decimal. So binary to decimal, in this conversion, binary number to a decimal number, we use multiplication method in such a way that if a number with base n has to be converted into a number with base 10, then each digit of the given number is multiplied from MSB to LSB with reducing the power of the base. Let us understand this conversion with the help of an example. So we have to take one example, then we can understand betterly. So suppose here in this conversion, what is conversion means? Binary to decimal conversion. We use multiplication method. So we have to take what are the values I'm taking. We have to take multiplication method, and it is a LSB bit, and the last one is the MSB, and it is converting to the what is the base now? Converting to the base 10 means decimal. I'm converting, and each digit of the given number is multiplied from MSB to LSB. MSB to LSB we are multiplying, and with reducing the power of the base, so we are reducing the base. So MSB means most significant value, so that is a r power n, r power n minus 1, r power n minus 2, so on, r power 1, like this. And we are converting with the help of example we can consider. And here convert binary number 11101 base 2 to decimal equivalent. First I'm taking here, what is the value, what is the base? 11101 is nothing but a base 2. It is called base or radix, and it is called value. So here converting the binary number to decimal equivalent, we have to find out first what is the first step. 11101 base 2, 11101 base 2, it is a binary number, we are converting to the decimal number. What is the step 1? Step 1 is nothing but I'm taking the values from LSB to MSB. So first I have to find out the positions, how many positions are there. So here 11101, so it is a 2 power 0 position, 2 power 1, 2 square, 2 cube, 2 power 4 position. Why? Because I'm taking 2 means here the base is 2, so that is the reason I'm taking 2 power 0, 2 power 1, 2 square, 2 cube, and 2 power 4. So here 2 power 4, how many are there? 1 2 3 4 5 positions. So here first 2 3 4 5 positions are there. So what is first one means? Here it is a MSB, it is a LSB. So we are starting from MSB to LSB. So MSB to LSB means 2 power 4 to 2 power 0. So 1 into 2 power 4 plus here 1 into 2 power 4. 1 into 2 power 4 plus 1 into 2 cube. 1 into 2 cube plus 0 into, sorry, plus 1 into 2 square plus 1 into 2 square plus here 0 is there, 0 into 2 power 1, and here 1 is there, 1 into 2 power 0. So here 2 power 4 means 16 into 1, 16, 2 cube means 8, and 2 power 2, that is 2 square into 1, 4, here 0, anything into 0 means 0, and 2 power 0 means 2 power 0 equal to 1, 1 into 1, 1. So base 10, 16 plus 8 plus 4 plus 0 plus 1. Total is 29, base 10. So finally the binary value 11101 base 2, we are converting to the decimal. What is the value finally? 29 base 10. So here it is the method converting from binary to decimal. So example 2, here nothing is there. What are the values I'm taking here? 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4. So how many digits are there means 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So here LSB and MSB. So it is a binary or not? Yes, it is a binary converting to the decimal. So what is a radix or base? This base or radix we are multiplying with value. So here base is 2 power 0. 2 power 0 into 1 like this. So here 2 power 4 into 1 plus 2 cube into 1, 2 power square into 1 plus here 0, 2 power 1 into 0 plus 2 power 0 into 1 like this. So 16 plus 8 plus 4 plus 2 plus 0 plus 1. 16 plus 8 24, 20, 2 power 4 16, 2 cube 8 plus 4 plus 2 power 0 into 0, 2 cube 8, 2 square 4, 2 power 1 means it is 0, and 2 power 0 means 1. So 16 plus 8, 24 plus 4 plus 1, that is a 29 base 10. So we are converted to the decimal. Example 2, 101011 base 2, converting to the binary. So what is the process? So here 101011. So here 2 power 0 position, 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5. So how many positions? 1, 2, 3, 4, 5, 6 positions are there. So we have to take MSB to LSB. MSB to LSB. So what is the process? 1 into 2 power 5. Otherwise we are going from like this. 1 into 2 power 0. Here 1 into 2 power 1 plus 0 into 2 square. Next 1 into 2 cube. 0 into 2 power 4 plus 1 into 2 power 5. So 2 power 0, 1 into 1. 2 power 1 means 2 into 1, 2. Here 0. 2 cube means 8 into 1, 8. 0 multiply with anything 0. 2 power 5 is 32. 32 plus 8 plus 2 plus 1. 43 base 10. So finally we got 43 base 10. So what is the input value? 101011. So our binary is converted to the decimal. So these are the integer values. Binary to decimal. First one is a integer value. Second one is a floating point value. Floating value. Integer value means 10111011. Example base 2. Floating point means 10111011 0.011. Example. So like this. So fraction values. After 0 point, the fractional values are there. So these are the fractional values. So when we getting the fractional values, that is called floating point values. It is also called floating point value. So integer value and floating point value. So up to now we discussed integer values. Now we are going for the floating point numbers. So floating point means point something. Suppose I have A4, A3, A2, A1 like this. Example 31101. Example 011. So it is a A0, means R0 position, R1, R2, R3, R4. So A0, A1, A2, A3, A4. So after the dot, after the full stop, we are taking the floating point values. Floating or fractional values. So these fractional values I am taking R power minus 1, R power minus 2, R power minus 3. So here A minus 1, A minus 2, A minus 3. Minus 1 means fractional values are there. So we are going for the minus values. Example, this one we can understand easily from example 1011.001 base 2. So here 1011.001. Here 2 power 0, 2 power 1, 2 square, 2 cube. Here 2 power minus 1, 2 power minus 2, 2 power minus 3. So 1 into 2 cube plus 0 into 2 power 2 plus 1 into 2 power 1 plus 1 into 2 power 0 plus 0 into 2 power minus 1 plus 0 into 2 power minus 2 plus 1 into 2 power minus 3. So it is a process. So here I am taking 2 cube equal to 8 plus it is 0 plus 2 power 1 means 2 plus it is 1 plus it is 0 plus 0. 2 power minus 3 means 1 by 8. So 1 by 8 means 0.125. So 8 plus 2, 10, 11.125. So it is a 11.125 base 10. So it is a fractional values. So we got fractional values like this. Another method is a octal to decimal. Octal means base 8 to decimal. So you can take any of this one, 190, 746 base 8 convert to decimal. So to convert octal to decimal, we multiply the digits of octal number with the decreasing power of the base number 8 and starting from MSB to LSB. MSB to it is LSB and it is MSB. MSB to LSB. So add together. So we are adding each with radix value or base value. So what are the 746 base 8? We are going from MSB to LSB. What are the positions are there? 3 to 1 position. So we are multiplying with MSB to LSB with radix value. We are multiplying with the radix value. We can take one example, then understand easily. Step 1, convert the original number to a decimal number, that is base 10, and convert the decimal number. So obtain to the new base. So what is output? We have to convert to the base 10, that is important. Okay, it is the output value, and convert the decimal number, so obtaining the new base value. So what is the radix you have to take? You have to convert to the decimal. So octal number 25, here I am taking one example, base 8 to decimal equivalent. 25 base 8 to 10. So here 25 base 8. So here 25 base 8, that means 8 power 0, 8 power 1, first question, second, MSB, LSB. So we have to take from MSB to LSB. So here, MSB to LSB, 2 into 8 power 1 plus 5 into 8 power 0. So 2 into 8 power 1 means 2 into 8 plus 5 into 8 power 0 means 1. 8 into 2, 16 plus 5. How much? 21. Base 10. Why? Because I am converting to the decimal. Here also 25 base 10. So 2 into, it is 8 power 0, 8 power 1. 2 into 8 power 1 plus 5 into 8 power 0 base 10. 2 into 8 power 1 means 16 plus 8 power 0 equal to 1 into 5. 16 plus 5, 21 base 10. So what is the 25 base 8? We are converting to the 21 base 10. So octal to decimal conversion. Another example, convert the octal number 724 base 8 to decimal conversion. 724 base 8 converting to the decimal number. So 724, 8 power 0, 8 power 1, 8 square. So MSB to LSB. It is the MSB value and it is the LSB. MSB to LSB. That means 8 square into 7 into 8 square plus 2 into 8 power 1 plus 4 into 8 power 0. So 7 into 8 square means 64 plus 8 into 2, 16 plus 4 into 8 power 0 means 1, 4 into 1. So plus 16 plus 4 into 1 is 4. 448 plus 16 plus 4. 468 base 10. So 468 base 10. So 724 base 8. 724 base 8. The value is after decimal. The value is 468. So it is a process of converting from octal to decimal. So octal to decimal is nothing but we have to take. Suppose I am taking 547 base 8 to 10. 8 power 0, 8 power 1, 8 square. So what is the radix value? This radix value we are multiplying with the value. So here 8 radix is there, 8 power 0, 8 power 8 square. Suppose it is a 16 radix. We are multiplying with 16. If it is 2, we are multiplying with 2. So 8 square into 5 plus 8 power 1 into 4 plus 7 into 8 power 0. So like this, 16 into 5 plus 8 into 4 plus 7 into 1. 80 plus 32 plus 7. 80 plus 32. 112 plus 7. 119. So 547 base 8 is converting to the 119 like this. It is one example. and convert 246.28 base 8 into the decimal number. So start from right hand side, so right to left. So first one, 2 into 8 square plus, why? Because 840 841 8 square, so it is a fractional value. Okay, fractional value. So fractional value 246.28. 246.28. So 2 into 840 plus 4 into 841 plus 6 into 840. It is a 8 power minus 1, 8 power minus 2. So 2 into 8 power minus 1 plus 8 into 8 power minus 2. So equivalent of the power of value 8. So it is 8 square into 2. 8 square means 64. 8, 8 power like this. So here 8 square into 2 like this. 2 into 64 plus 4 into 8 plus 6 into 8 power 0 means 1, and here 8 power minus 1. What is the 8 power minus 1 means 1 by 8. So 2 into 1 by 8 plus 8 into 8 power minus 2 means 8 into 1 by 64 like this. So here 2 into 64 means 128, 4 into 8 32, and 6 into 1 6 plus 2 into 1 by 8 0.25, 8 into 1 by 64 0.125. So finally what is the value means we are getting 128 plus 32 plus 6 plus 0.25 plus 0.125, 166.375. Therefore 246.28 246.28 base 8 is equal to 166.375 base 10. It is a final value. So this octal value we are converted to the decimal, 246.28. So 2 into here 840 841 8 square. So 2 into 8 square plus 4 into 841 plus 6 into 840 plus 2 into 841 plus 8 into 8 power minus 2. 2 into 64 plus 4 into 8 plus 6 into 1. 2 into 1 by 8 plus 8 into 1 by 8 square. 128 plus 32 plus 6 plus 0.25 plus 0.125. So that is 166.375 base 10. So we are converted from octal to decimal. Converting from fractional value 147.3 to decimal conversion, 147.3 to decimal conversion. So here 8 power minus 1, 8 power 0, 8 power 1, 8 square. So 8 square into 1 plus 8 power 1 into 4 plus 8 power 0 into 7 plus 3 into 8 power minus 1. So it is a 64 plus 32 plus 7 plus 8 power minus 1 means 1 by 8. 3 into 1 by 8. That means 3 by 8. So 3 by 8 value is 0.375. So totally 103.375. So 147.3 convert to 8 decimal equal to 103.375 base 10. Okay, octal to decimal conversion is completed. Next, hexadecimal to decimal conversion. To convert hexadecimal to decimal, we multiply the digits of octal number, or here octal means we are taking the hexa numbers with decreasing the power of the number 16 starting from MSB to LSB together. So convert hexadecimal ABC by 16 to decimal value ABC to 16 to decimal value. So why I am taking ABC here means already we know that 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After 9 we have to take A, B, C, D, E, F. Here A means 10, 11, 12, 13, 14, and F equal to 15. So here A means 10, B means 11, C means 12. So A means 10. So A equal to 10 into 16 square, 16 power 0, 16 power 1, 16 square. So A into 16 square. A into 16 means 10 into 16 square, that is 10 into 256. Here B means 11, 11 into 16 power 1, that means 16, and C equal to 12. So 12 into 16 power 0 equal to 1. So 10 into 256 plus 11 into 10 into 256 plus 11 into 16 plus 12 into 1. So 2560 plus 11 into 16 176 plus 12 into 1 12. Totally we got 2748 base 10. So the ABC base 16 converted to the decimal. What is the value here means 2748 base 10. So hexadecimal is converted to the decimal value. Here another conversion of A to F by 16 to decimal conversion. A to F 6040 16 square 16 cube. So what is the A value here now? A means 10 into 16 cube plus 2 into 16 square plus F equal to 15 into 16 power 0. So A means 16 square, say 2 into 16, F you make 15, 10 into 16 square, 2 into 16 square power 1, 16 power 0, extremely sorry, 16 power 0, 16 power 1, 16 square. So here 10 into 16 square plus 2 into 16 power 1 plus 15 into 16 power 0. So 10 into 16 square, 2 into 16 power 1 plus 15 into 16 power 0. Here 2607. So 2607 base 10 A to F. A to F hexa is converted to the decimal value. So here converting 1 to 1 base 16 to decimal number, 1 to 1 base 16 to decimal numbers. So 1 to 1 16 power 0, 16 power 1, 16 square. So 16 square, what is the value here? 1 into 16 square power 1 into 2 plus 16 power 0 into 1. So 16 square plus 60 power 1 into 2 plus 60 power 0. The value is 289 base 10. So what is the input value? 121 base 16 converting to decimal means 289 base 10. So floating point representation of hexadecimal value. Convert the hexadecimal number 1f.01b into decimal number 1f.01b 16 to decimal value. Here B and F are the 11 and 15. So 16 power 0, 16 power 1. So 1 into 16 power 1 plus F into 16 power 0. F means 15 plus 0 into 16 power minus 1 plus 1 into 16 power minus 2 plus 11 into 60 power minus 3. Here in place of F we have to take 15. So finally what we got the value means 31.006591.8. It is a decimal value. So hexadecimal 1f.01b converted to decimal means 31.006591.8. So it is a floating point representation. So these are the references. Today we discussed any radix to decimal conversion. Any radix to decimal means we are converting from decimal to binary, decimal to octal, decimal to hexa. Previously we discussed. Now any radix to decimal. Any radix means maybe it is binary to decimal, octal to decimal, hexa to decimal. Okay, binary to decimal, octal to decimal, hexa to decimal. So binary to decimal 1, octal to decimal 2, hexa to decimal 3. So 3 types of possibilities are there. So we have to find out binary to decimal. I am taking the binary value. I am multiplied with the radix value. It is a binary value 11101. So it is a base value. So this radix value multiplying with our value. So here MSB to LSB I am taking. So 11101 base 2. It is a 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4. So 0 position 1, 2, 3, 4, 5 are there. Here MSB and it is a LSB. We are going from MSB to LSB. That is from 2 power 4 to 2 power 0. 2 power 4 to 2 power 3, 2 square, 2 power 1, 2 power 0. Like this. I am getting finally binary to decimal value. Here another example from binary to decimal. Here it is a binary to decimal with floating point value 1011.001 base to converting to the floating point. It is a floating point 001 rational value. We are converting to the decimal. And octal to decimal. Here what is the process means? Same radix value. What is the radix here? 25 base 8. This radix value I am taking here 8 per 0, 8 per 1. So 8 per 1 into 2 plus 8 per 0 into 5. Finally, we got the value 21 base 10. So 25 base 8 to 21 base 10. It is another value of octal to decimal 724 base 8 to decimal conversion. 4 into 8 per 0, 2 into 8 per 1, 7 into 8 square, like this. And we are converting floating point value 246.28 base 8 to the decimal value. Here we are getting 166.375 and converting the floating point value 147.32 decimal. Finally, we got 103.375. So, what is the floating? We are taking as a 8 power minus 1, 8 power minus 2, 8 power minus 3, so on. Here, finally, going for hexa to decimal. So, hexa to decimal. A, B, C are the hexadecimal values. Because after 9, 10, 11, 12, 13, 14, 15. So, 15, 0 to 15 are called 0 to 15 called hexadecimal values. Hexadecimal values. So converting from hexadecimal A to F to decimal conversion. So like this 2607 base 10. Here 121 base 16 to decimal value. So here 16 power 0, 16 power 1, 16 square. So 16 square into 1 is 16 power 1 into 2 plus 1 into 60 power 0. Finally called 289. So 121 base 16 to 289. Floating point representation of hexadecimal to decimal. 1f.01b. So it is called the floating point representation. And I am taking as here 16 power minus 1, 16 power minus 2, 16 power minus 3. Here 16 power 0, 16 power 1. So 16 power 1 into 1 plus f means 15 into 60 power 0 plus 0 into 60 power minus 1 plus 1 into 60 power minus 2 plus 11 into 60 power minus 3. Finally, we got 31.006591 base 10. So 1f0 1f.01p base 16 converted to decimal. So these are the references examples. So finally, we got hexa to decimal conversion. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.